It says, put in the subscripts for M, R, and F, the vectors, in the equation below to determine the moment about point O due to the force, and the force is going from A to B. So let's go around. Daniel, what subscript would you put at M? Oh, how come? Because you're trying to find the moment about point O. Okay. Daniel? Other Daniel. Let's do F. What subscripts would you put for F? So would it be BA or AB? AB. And why AB? Force is going from A to B. Okay, Ethan. Now we're looking at the R. So what subscript should R have? Say it again. We're talking about the subscripts. And R is not a unit vector, right? Because R represents a distance. Heather, which should the subscripts of R be? O to A. And why? Okay, so everybody look up here. Here's point O. And this is where I want to find the moment about. And here is my force. It goes from here to here. This is A, and this is B. So where is my R vector? My R vector goes from where to where? From O to A. So R, O, A. Questions? Everybody got this now?
Yes.
The subscript for the moment is the point you're finding the moment about. The subscript for the force is where you're going from and to. And then, what's the R vector? And the way I remember is I always do this. I know I'm going from O to A because I want to go to the tail of the force. Hang on, Danny. Okay, now, did everybody grab all the sheets up here? Okay. So take one, or if you have one, don't take one. Charlie? Do you have one? Take one and pass it. And then here's a second sheet. Take one only if you haven't taken one yet. So I'm looking at this one. Everybody with me? So I'm calculating the moment about what point? What am I calculating the moment about? I want to hear voices.
Oh.
So you guys, everybody's going to get a 10 on this quiz because I'm having you do it. So I want everybody to smile, right? And get less stressed. I know you're stressed. You're taking a bunch of hard classes at the same time. Okay, so just calm down. It's okay. All right, and I want people to answer me. So where are we trying to find the moment about? Oh. So here, I'm trying to find the moment right here at the origin. And using what we just said, where does the force go from and to? From B to C. Does everybody agree? Already you got quiet. Does everybody agree that the force is from B to C?
Yes.
Yes. So what is R from? R is going to be from O to B. So R is from O, draw it on the sheet. R, O, B goes from the point I'm going to find the moment about to the tail of the force. And notice what value I got for the moment. Everybody look up here. I got negative 120I plus 139.5J minus 209.3K. But now, look after the squiggle line here in the middle of the page. I'm now looking at the moment. What's different about this cross product versus the top one? What's the difference between cross product 2 and cross product 1? R is different. Instead of R going from the point I'm finding the moment about to the tail of the force, where is it going to? The head of the force. Everybody look up here. On this problem, my R went from the point I'm finding the moment about to the tail of the force, and that's standard how I always do it. I try to do every problem the same way so I don't screw myself up, especially like on an exam. But I just did the problem with R going, still comes from the, does this still come from the point I'm finding the moment about? Yes, it's still coming from the point I want to find the moment about, but it's to the head of the force instead. And what do you notice about the answers?
Slightly different.
Yeah.
They're slightly different, and why do you think they're slightly different? It's a rounding error. Okay, they should be exactly, it's just I'm rounding. What I rounded here to 1 decimal place. So it's just a rounding error. So in the end, are these values the same?
Yes.
They are the same. Which means what? What does that mean when you do your cross product? Tell me what that means about the R vector. Heather? Oh no, you already went. Julia? What does it mean about the R vector? If I could draw the R vector from O to the tail of the force, and from O to the head of the force and get the same value, what does it tell us? They're not the same length. Gracie? They give you the same answer though, right? What do you think would happen if I drew R to here? Or R to here? Or R to here? Or R to here? What do you think would happen? I would get the same answer. Because remember, what is the cross product? Go back to your quiz. When I cross two vectors, if I cross vector A with vector B, what does it come out to be? Matt?
Yeah, and that would be the vector perpendicular to A and B.
It gives you the vector that's perpendicular to A to B, right? So that means if I have a vector here, and I have a vector, it doesn't matter what plane it's on, it's still going to give me a vector coming off. Okay, so here's my force vector. My R vector is still in the same plane. As long as my R vector hits any point on the force, it's going to give you the same value. So what am I trying to tell you then? When you're determining what your R vector would be, your R vector always comes from what? Which point?
The point of the moment.
Point I'm trying to find the moment about. And where does it go to? Any point on the force. Okay, so let's go back to the quiz. This is correct, but tell me what else would be correct.
R from O to B.
From O to B. And anywhere from A to B, but we don't have any other letters, so both of these are correct. Okay, tell your neighbor what you just learned. Make sure that everybody knows it.
The moment you're calculating about is the position vector is independent. Sorry, the moment is independent of that of the position vector. As long as your position vector runs anywhere along the course between from where it starts to where it ends, it's going to give you the same.
Okay, so the R vector has to start at what point? The point you're finding the moment about. And where does it end?
Anywhere
along the force. So probably you're going to do the tail of the force or the head of the force, whatever you get distances for. Okay. Okay, I want you to answer this question. What is R and what is the unit vector going from A to B? Mike, are you going to answer it?
Yeah.
Just write it down. Everybody do it. Write it down. Just put it on the back of the quiz. Okay, check with the person next to you. Make sure you're on the same answer.
Yeah, this is not math.
I know. I don't like it.
Or no, exactly.
Yeah.
Make sure you write down what quiz it is, just like you did here. So here's the attendance. So now you know who got a 10 on this quiz. Only the people who are here.
Now, tell me what the relationship is between E and R.
Yeah.
Give me an equation. E to the AB is equal to, tell me the relationship between these two. Okay, so this is 4I plus 3J meters. Right, this is 4I plus 3J over, over 5, which turns out to be whatever it turns out to be. So what's the relationship between E and R?
E equals RAB divided by the magnitude of RAB. That's correct.
Okay, do you guys agree?
Yeah.
So you have to be careful about these two because many times people mix them up. Which one has a unit on it? R. Should R always have a unit on it? Why? It's a length. It's a length. It has a unit on it. But the unit vector has no unit. Okay? So be careful of this. You know the difference. And I knew even before I covered this, you knew the difference between these two. But sometimes you mess up on homework and exams on this. So make sure that you're comfortable with the difference. Okay? Okay, let's go back to the quiz. Number 3. The dot product of vector A and the unit vector BC can best be described as, ask the person next to you, what is the answer? We're on number 3 now. What's the answer? A. It's the component of vector A in the direction of BC. Cross product, does the cross product give me a scalar or a vector?
Vector.
Cross product gives me a what?
Vector.
Vector. The answer has to be a vector. How about the dot product? The answer is a what?
Scalar.
Scalar. Be careful with that. If I have a 2D, two-dimensional force problem and you're calculating moments, what is the moment about? Let's try it again. I have a two-dimensional problem. The forces are in the XY plane. What are you finding the moment about? Z-axis. Remember that. Okay. Sometimes people give me answers in I and J, but it's all in Z. If you're looking at the 2D plane, the moment's in the Z. So let's do this. What I wanted you to do, using the right-hand rule, determine the moment about point A. Here's A. Due to the force at B. What's the answer?
0.
0. Why?
Translational.
Few answers. One, there's no lever arm, right? There's no distance. 2, which is the same thing, the force goes right through the point. If the force goes through the point, there is no way it can cause it to turn, which is the solve, and the kind of motion that 275 can create on A is only
Translational.
right. So the 275 can only pull A down. It can't cause it to spin. How about this force of here, 750? Can that create a spin about A? Yes. So, looking at this should be number 5. Number 5, the first they want you to do, I want you to do right-hand rule, right? So what you're trying to do is you try to find this perpendicular distance. But geometry, to me, it's too complicated. So what do? You break the force into components, right? First step, look to see if you have the perpendicular distance. If you don't, break it into components. So tell me what Fx wound up being. What was Fx? Say that again. 614? 0.4 I. And what was it in the J?
3.2.
Okay, is this the answer right here?
No.
No, why is not that the answer? I forgot, well, sorry.
Oh.
It's not,
Units.
you got units. Okay, so it's 614.4 in the X and 430.2 in the Y. So doing right-hand rule. So the moment about, what point are we doing? A is 430.2 times, the force is in, everybody follow me, in the Y. The moment I'm trying to find is about the Z, the distance has to be in the X, the perpendicular distance is the X. I use my right-hand rule and I get a positive. 614.4, I'm trying to find the moment about point A. I'm looking at this distance, it's 2, so it's 8. Fingers go in the direction of the force, palm goes towards there, I get a positive, and the answer comes out to be some number. What's the number? 8,356. Okay. What point? 0.4. And what's the units?
Inch pound.
Inch pound. Positive or negative? It's positive. You don't have to put the positive sign if you don't want to. But I wrote, be sure to include I, J, and K to show the direction. Which do I have here?
Okay.
Okay. Okay, any questions out loud or ask the person next to you? Okay, now we want to use vectors. So it's M is equal to R cross F. Moment is equal to R cross F. The subscript of the moment should be A. The F should be C. And R should be
A to C.
A to C. So what's RAC? From A to C, it's 8I minus 8J. Units? Inches. And we already know what F is, right? So the moment about A equals, what do you put in the first row? IJK. 8, negative 8, 0, 614.4, 430.2, 0. This minus this, so it's going to be equal to 8 times 430.2 minus a negative 8 times 614.4. It's all in the K. And what's the unit? What's it kind of turn out to be? Do you get the same answer? K inch pound. Do you have a question? It's okay, it's close. It's no, they're just rounding errors. Okay, can I have yours? Okay, you guys. That is equal to. Okay, looking at the whole thing. Okay, notice what happened, you guys, this is important. Notice what I did. I solved for the components of my force. And then what do I do when I solve for the components? I do a check. right? 614.4 squared plus 430.2 squared under the radical, it should turn out to be, what should it turn out to be? 750, and I checked it, and it's okay. What's the difference between doing it like this and doing it like this? So what did this person do here? Did they do any check first?
No.
So they didn't solve for the components first. I know you can take it, so I'm doing it. You gotta find the components first. Don't just plug the stuff in like you did in physics. Find the components. Look where my pen is. Find the components. Why do you find the components first? You can check it. Find the components and check it. Don't just do the math in here, because if you get this wrong number, you have no ability here to check. If you find the components and you check, you find your error first before you go into here. I know this is quicker. It's quicker. But if you get the wrong answer, you have no way to check anything. Okay. So keep your quiz. Ben reported 10 for everyone.
Thanks, Ben.
Yeah, he's such a nice guy.
Tim said he'll buy you dinner.
I'll take credit for that. Writing good.